Okay, so today we're going to be talking about parallel lines. Okay, and so if you start with a parallel line, so parallel lines, and you draw a transversal. Transversal is like a train who connects two parallel lines. Okay, now I'm going to take that back. You can start with parallel or non-parallel lines, and then you can draw transversal through them as well. Okay, and so we're going to start with either parallel or not parallel lines. We're going to draw transversal to connect those two lines. Okay, and then we're going to say, oh, look there's a lot of angles that are formed between those. And so to start us off, we're going to start with anytime you connect two lines, you get four angles formed. And remember, we call the angles that are formed vertical angles, the ones that are opposite from each other. Okay, and those will be congruent by the vertical angle theorem. Okay, we can call them vertical angles by definition, and we can say by the vertical angle theorem, they are congruent. Adjacent angles are angles that have a common vertex and a common side, okay, and they don't overlap. And then also a linear pair is if you start with a line and you break it up into a pair of angles, those are called a linear pair, okay? And then by the linear pair theorem, they'll be supplementary. And by the definition of supplementary, we can say that they add up to make 180 degrees. Okay, so today we're going to be talking about lines and planes. Okay. And so if you have parallel lines, that means they are on the same plane. So start with a flat sheet of paper, okay, or a plane, and then we are going to draw lines that are parallel. How you mark them to be parallel is you use those little triangles. See those little purple triangles there, okay? So if you see arrows on two lines, kind of midline, you'll know they're trying to say that those lines are parallel to each other, okay? At the end, that just makes a line, but in the central part of it, those arrowheads show that say, hey, these lines are parallel. And so to talk about them being parallel, we can say, line K, and no, it's not line K. We would say JK is parallel to LM. Okay, and so something to look for in the diagram would be those arrows or the arrowheads, okay? And so, of course, any line has arrows on both sides of it, but if it has those ones in the middle, then you know that they're going to be parallel. Okay, the next thing would be if you've got lines that don't intersect or that are going to be not intersecting, but they're not actually parallel. And so we can do that if we incorporate additional planes. Okay, if you go into 3D space, and you draw two lines, and I would think like airplanes, okay? Even if airplanes, if they pretend they just flew straight, airplanes are not going to intersect, okay? They're going to be flying through 3D space and not intersect. And so if they're not parallel, but they still don't intersect, we call that skew, okay? And so we don't really label that in a diagram as skew, but and this is how you write it, and that's kind of what it looks like. And so if you had like a rectangular prism, okay, and so or a cube or something like that, and we're going to focus on that. Or if you had like a pyramid or something like that. I'm going to draw that real quickly. Lines, oh, that looks terrible. I'm using my finger because my pen quit. If you've got a pyramid, two lines that would be skew, and they're not parallel would be, let me get another color, would be, say, like this line right here, okay, is skew to, say, this one down here. Do you see that? They're not going to cross, but they're certainly not parallel, are they? Okay, and so that's a really good example of a skew line is not parallel and not going to cross because we use 3D space. And so, as we talk about them on, rectangular prisms, we'll see those in a second too. On planes, okay, planes can be parallel, okay, and remember they go forever. So even if they don't intersect yet, if they're not parallel, they will intersect. And so, but planes can be parallel, and where none of them are in common, they'll never intersect. And then also we have lines that are perpendicular. So if you go to a flat surface and you draw a 90-degree angle, you know that it's going to be perpendicular. And so one thing to look for that would be perpendicular like this, or you might see like a 90-degree angle here. Okay, and so And you could say segment like AB is perpendicular to, BC. Okay. And so be like, oh, look at this, they're perpendicular. So another thing we should look at would be on a 3D diagram. Okay. Notice how they mark who's perpendicular and who's parallel. Okay. The only things that they've marked would be that there's a perpendicular, two perpendicular lines here because it has a right angle. And also this one at the top. Those are the ones that we know for sure are. Now, sometimes we can use some of our perpendicular properties to say, oh, if those two are perpendicular, then we know something else. But at this moment, the only two things that are given would be those two lines are perpendicular to each other. We really don't know down here if anybody's perpendicular yet. Okay. Again, we may be able to use some theorems, the right angle theorems, to be able to say, okay, if we know this, then we know something else, but the givens are only those two. Same with the parallels. Okay, it appears that there's a lot of parallel lines. However, it's only marked that these two lines are parallel, and it's also marked that these two lines are parallel to each other. Notice how they have a common arrow set, so you know who links with whom. Okay, so again, we can probably use some theorems to help us say, oh, if we know this, then we'll know something else. But the givens are only those two pairs of parallel lines. Okay, so I want you to keep that in your brain. You should not assume things are parallel if it's not told to you in that way. Okay, nor should you assume that things are perpendicular. You can go with your givens, and then you can also go with theorems that you know to say, if I know, you can deduce or use deductive reasoning like a proof type thought to say, hey, if I know this, then I can say this next thing. And again, that's why we do proofs, not because you're going to do formal proofs in your life, but you do need to be able to think logically and say, if I know this, what can I assume as a result? Okay. And so the first thing says AB is parallel to which segments? Okay. And so AB, let's find her. Segment AB is right here. And she's parallel to which segments? Oh, you can see the ones that are marked. Okay. It's going to be segment DC. Okay. And you can also see EF. And then BF is perpendicular to which segments? Okay. So BF, okay, she's over here. Okay. She is perpendicular to segment AB because you see the little, and then you see the right angle mark there. Okay. And who else is she perpendicular to? Okay. Well, this is where we're going to use our right angle theorem. If AB and EF are parallel, okay, and AB is perpendicular to BF, we can know that if it's two lines are parallel and one line is perpendicular to the one, another segment is perpendicular to that line, the other one will also be perpendicular to it. And so therefore, we know that actually, it's going to be a theorem that we learn this chapter. It's related to perpendicular lines theorem. We're going to be talking about, it's called the perpendicular, I'm looking up the exact words. Okay. The perpendicular transversal theorem. In a plane, if a line is a transversal is perpendicular to one of two parallel lines, then it will be perpendicular to the other one. Okay. And so you can gather that that's true. If you've got lines that are parallel, you know, if there's a line that's perpendicular to one, it's going to be perpendicular to the other. So that is going to be the other answer. Okay. So let me get this for us. And that's going to be EF. Okay. All right, name two segments to which AB is skew. So AB is our red line. Things that are skew, again, they can't be parallel, but they're not going to intersect. Okay, and so two segments that are going to be that would be, it could be on DH. Excuse me. And you could also say CG. I don't know why I put a line after it, but CG. These two lines will be not parallel, and they're not going to intersect with it. Could you put HG? Well, no, because likely those are parallel. Okay, and so even across space, if you could make a plane between them and they are parallel, then the truth is that is not going to be considered skew. Okay. In a plane that is parallel to ABC. Now, the reason why they use that shape in front of ABC instead of the word plane is, planes go forever. And what we're talking about is the plane that's going to be not infinite. We're talking about the plane that is going to be the flat surface of this figure. Okay, so they're saying quadrilateral ABC. Okay, it should actually be ABCD. Okay, so the next one says name a plane that is parallel. And instead of writing out the word plane, I believe that we're just using a shortcut here. Okay, and so I don't know that this is a commonly recognized shortcut. So in general, to formalize, you should write the word plane. The other thing would be, if you're talking about a quadrilateral, sometimes you put a picture of a quadrilateral and you name it by the vertices. So the most formal way to do this would be quadrilateral ABC. In this case, it would be D. Okay, so I'm going to add that just to formalize what we're doing. If you're talking about a plane, obviously, you just need 3 points on the plane. But we're going to assume we're talking about the quadrilateral here. And I want you guys to be precise and formal with your words. Okay, so who is going to be parallel to that quadrilateral ABCD and the plane also? Okay, the plane that would be parallel to that would be, because you see that the AB is parallel to EF, so we know the planes will be parallel as well. And so I'm going to write plane, and I'm going to say EFG. Okay. I could have said quadrilateral EFGH as well, but most formal would be plane EFG. And then the next one, name a plane that is perpendicular to a plane ABC, or we could say quadrilateral ABCD. And that the one that's going to be perpendicular to it, notice you can tell that segment AB is perpendicular to BF. So you know the plane will be perpendicular as well. So I'm going to write plane, and we're going to do ABF. Okay, so again, you can use your logic and your skills to say, if I know this, then this is the result. Okay, so the next part would be to talk about some angle relationships. If you have two lines, whether they're parallel or not parallel, and you draw a transversal that between those two lines, the transversal is the one that connects the two lines that you started with. Okay, and so a train connects those two. The other two obviously are not going to be transversals because they're not connecting the other two lines that you started with. So when you draw a transversal, every time you make an intersection, you make 4 angles. And so we're going to talk about naming these 8 angles that are formed when you have 2 lines and then you draw a transversal between them. And so you're going to need to know these, but they're pretty logical. So I want to teach you how you could logically get to those. Okay. First of all, the transversal is a line that connects 2 coplanar lines. Okay, they may or may not be parallel to start with. A lot of times the most interesting ones are when they are parallel, but we're going to start with ones that aren't perhaps and talk about the names of all 8 angles that you see. Okay, and so the first thing, so T is the transversal here. Okay, and so that connects the original 2 lines that were there. So we've got corresponding. Okay. If you correspond with somebody, you're writing them letters. Another thing would be is if you think about where you sit in all of your classes, do you have any 2 classes where you sit in a kind of the same relative position, like the front right or something? So maybe you sit in Spanish class in the same spot as you sit in my class. Who knows? But corresponding is the same relative position. So corresponding angles are going to be the same relative position in the 2 intersections. So you've got 2 main intersections. And notice, if you look at angle 2, okay, who is going to be corresponding to angle 2 in the bottom group of angles? Well, that would be angle 6. Okay, so 2 and 6 are going to be corresponding angles. Yes, they're in 2 different intersection parts. Okay, so the 2 different intersections are going to be, the top one is going to be 1, 2, 3, 4, and the bottom one's going to be here. But if you think about it, 2 and 6 correspond. They're both on the top right. Okay, and think about 2 others that might correspond. That would be like 8, okay, and say 4. They're both in the bottom right. Okay, so 8 and 4 are going to be corresponding with each other as well. Okay, and then another one would be 1 and 5. that's a corresponding pair because they're both in the top right of their intersection, okay? And then the bottom two would be 3 and say 7. Okay, so corresponding is that the formal definition would be they lie on the same side of the transversal, okay, left side or right side, and then also on the same side of the intersected lines, okay? So bottom left of both intersections, okay? So you can even think about you're driving between those two intersections. And so if you're driving between those, the same relative position or corner on the intersection would be what you're talking about. And so that's a good thing to hold on to, and we'll practice it so you can kind of check your knowledge. Another thing would be alternate interior. So, okay, let's talk about this. Okay, if you start with 2 pieces of bread, okay, two lines, okay, and between them is called the interior, okay. And so all 4 of those angles are interior between those original 2 lines. And then exterior would be outside of them, okay, right here. And so that's a good important thing to say. Your 2 lines that you start with, the transversal just connects those two lines. So between the 2 original lines is going to be interior, and outside them is going to be exterior. And what we're going to say is alternate interior. So alternating sides of the transversal would be 3 and then also 6. Okay, so we can leave that. So, okay, angle 3 and 6. Okay, those are alternate sides of the transversal, left and right sides of the transversal, and also on the interior of your original 2 lines. And then another group of alternate interior would be 4 and 5. Okay, so that's a good thing to know. Alternate exterior angles. Again, let's get out our highlighter and say, okay, if we're talking about, okay, these are interior angles right here. Those 4 angles are interior, and these guys are all exterior, okay? We want to say which ones are alternate sides of the transversal, and then also exterior. So alternate exterior would be angle 1 and say 8. Okay, so angle 1 and 8. Angle 1 and angle 8. And then another set of alternate exterior would be 7, goes with 2. Okay. Again, they're alternating sides of the transversal. Again, the transversal is the line that connects the 2 original lines. So angle 2 and 7. I'm going to put angle and 7. Those are going to be alternate exterior. Okay, the next one would be same side interior. Okay, so let's get out our highlighter again. So interior are going to be all of these. You know, the exterior are going to be the outside ones. Same side interior, okay? Same side of the transversal and interior would be like 3 and 5. Okay, so angle 3 and 5. Angle 3 and 5. Okay, those are same side interior. And then 4 and 6. Okay, 4 and 6. So same side interior. So you just have to kind of know your vocabulary and say, okay, what is actually going on here? Okay, the next thing would be, let's actually name each of these things. So in class, I'm going to have people just go ahead and name them, okay? Use the vocabulary there as well as vocabulary you know in previous lessons, okay? So we're going to slide in there a little bit of like linear pairs and then also vertical angles. So don't be surprised if you see something else in there, okay? And so I'm going to go over these. 1 and 6, okay? 1 and 6 are going to be alternate interior. Okay. 7 and 2, okay? 7 and 2 are alternate exterior. You see how they're both outside the little sandwich? 2 and 5. Oh, 2 and 5. Look at this. 2 and 5 are right here and right here. Those are corresponding. Okay, do you see how they're both in the top left of each intersection? 4 and 6. Oh, 4 and 6. 4 and 6 are going to be same side interior. I'm abbreviating quite a bit because I'm writing with my finger and it's terrible. Okay, 1 and 3. Oh, 1 and 3. Look at 1 and 3. Those are going to be vertical angles. And then 8 and 3. Where is even 8? I can't. Oh, 8 and 3. Alternate exterior. Okay, let's focus on this. Do you see 8 is here and 3 is over here? They're exterior, but they're alternating sides of the transversal. So alternate exterior. They're not inside the sandwich. They're alternating sides of the transversal, but they're outside of the sandwich. And then 4 and 5 are alternate interior. Okay, let me see if my pen works, because that would be really nice now, but sometimes she does work. Okay, now, do you see this? You're like, I don't even know what the original lines are. I don't know what the transversal is. Okay, well, the truth is, if you look at this, there is, okay, so it asks us to talk about what is the relationship between angle 2 and 4, and is there, what transversal connects them? Okay, so the thing is, if they're not in the same intersection, okay, and you look at angle 4, okay, that's over in this intersection. Okay, the vertex of that point is here. And then angle 2 is over here, and that has a different vertex. So they don't have a common vertex. So they're in different intersection, from different intersection of two different lines. And so what line could you drive on to get from one intersection, one vertex to the other vertex? And the line that you could get on to go from one vertex to the other vertex of that angle would be line N, okay? And so this would be line N. Okay, so you find each angle and you say, okay, what line could you get on to drive from one intersection to the other intersection, one vertex of that angle to the other vertex, and that would be line N. And then, pardon me, I'm tired. That's the transversal, and let's classify those, okay? Of those two intersections, how would you name those things? And they would be corresponding. Okay, do you see how they're both on the same side of the transversal and they're both on the top left of the intersection points or angle, yeah, of the intersections. 5 and 6. Okay, I'm going to erase this and let's see if I can. 5 and 6, yeah, I got that. 5 and 6 are going to be right here, and 6 is down here. Okay, well, those two angles have different vertices, and so the line that walks from one vertex to the other vertex of those angles is going to be line P. Okay, so 5 and 6 would be line P. That's the transversal, the train you would take to get from one place to the other. And then comparing those two angles, those are going to be outside of the two main lines. The two main lines are right here, and so they'd be alternate exterior. Okay. So the two lines that you're talking about would be here, and they're outside of those two lines, and they're going to be alternating sides of the transversal. The transversal is this line right here. And so that's a little tricky to see, but they're alternate sides of the transversal, and they're outside of the main two lines that you're starting with. Okay, the transversal is the one that goes between those two main lines. And so, and we can talk in person if you come back to school. You're like, all right, let's talk about this a little bit more. The next thing would be 4 and 7. How are 4 and 7 related? Okay, like, well, they're not in the same intersection because they have vertices that are different. The line that connects those two vertices is going to be line M. Okay, and then they are going to be same side interior. So they're going to be between those two lines. Okay, and they're going to be the same side of the transversal. So it would be same side interior. Okay, so the two main lines of this are going to be here and here, and then this is the transversal right there. And so, yeah, it's getting a little muddy. We'll keep practicing this as well. Okay, those will be same side interior. The last one is 2 and 7. So 2 and 7, the transversal that connects those two vertices is going to be line P. And they're going to be alternate interior of those lines. All right. Well, thank you so much. Have a good day.